Hello there, Hydrauliac here. Today we will be learning how to calculate the theoretical torque output of a hydraulic motor. A common use of hydraulics is to rotate a shaft. You may see this on conveyor type applications, as well as on ground drive for large machinery. Torque is the rotational force a motor is exerting. To calculate the theoretical torque, we need to know two things. The first thing is the pressure drop across the motor. Whenever there is a pressure drop, energy is being converted into another form. Put simply, a motor converts the energy from pressure into the rotation of the shaft. So we measure the pressure on both the high and low pressure sides of the motor. This gives us the pressure drop across the motor. Next, we need to know the displacement of the motor. This is the volume of oil required to turn the shaft one full revolution. A bigger motor will have a higher displacement and more torque. And those are the only two things you need to know to find the theoretical torque of a motor. Let's look at an example. Here we have a motor with a displacement of 100 cc or 100 cubic centimeters. Our gauges show a pressure of 150 bar on the high pressure side and 20 bar on the low pressure side. Subtracting the low pressure side gives us a pressure drop of 130 bar. Now we will look at the equations to calculate theoretical torque. Notice the denominator changes depending on the units being used. Since we are using bar for pressure, we will plug our numbers into this equation, which gives us about 207 Newton meters of torque. If you've stuck with us this long, let's take a look at why this is the theoretical torque and not the actual torque. The first reason is volumetric inefficiency. You may have noticed that many hydraulic motors have a case drain line. Some of the oil is leaking past the internal surfaces inside the motor. Whatever leaks past is not being used to drive the rotation of the shaft. You'll see this even on motors without a case drain. In that case, the oil just leaks internally through to the low pressure side. We also have some mechanical inefficiencies. If you ever placed your hand on a hydraulic motor while it is running, you will have noticed they get very hot. Some of the pressure drop across the motor is also being converted into heat. Whatever energy is used to create heat will not be used to rotate the shaft. If you want to get a better idea of the actual torque output, you can match up the pressure drop and flow on the torque curves for your specific motor, or you can even go as far as using a torque measuring device. However, most people working with hydraulics have access to pressure gauges. This makes calculating the theoretical torque the easiest method. You just have to remember that there are some inefficiencies to account for. If you want to learn more about hydraulics, hit that subscribe button. Here we talk about everything hydraulic, from reading schematics to sizing parts. As always, thanks for watching.